yield-based bond duration measures and properties. So in the previous learning module, we looked at Macaulay duration, and in this learning module, we're going to look at how we use the Macaulay duration to calculate the modified duration, the money duration, and the price value of a basis point, and how these are affected by features of the bond. So what are the properties of duration? And this is, of course, they are all measures of interest rate risk. What that means is when you buy a bond, if the interest rates in the market go up, your bond price is going to come down, right? And we looked at the Macaulay duration in the last learning module, where we said if you have a short investment horizon, then this is something you're really worried about, because if the interest rates go up, your bond price will come down and you don't want to have to sell at that lower price. So how much of a risk do you face depends on how sensitive is your bond price to changes in interest rate. And that is what we measure through these three measures of interest rate risk, which is modified duration, money duration, and the price value of a basis point. Now, of course, all bonds are different, right? And depending on their features such as their maturity or their coupon rate or the yield level at which you're currently at, and let me just remind you what that is. So this is the chart that we saw for a bond's price and changes in yield to maturity, and we saw that there is a convex relationship over here with a much more steep slope over there and a much lesser steep slope over here. So why is this different? It's because of the low. So this part you can say is the low interest rate environment, because it's the low interest rate, right? So it's the low interest rate environment. And then similarly, this part is the high interest rate environment. So the yield level, which means is it a low interest rate environment or the high interest rate environment, that also affects interest rate risk. So we'll be looking at all these points. Starting with the first one, which is your mod D. So modified duration, we call it mod D. And what we looked at in the previous learning module is your Macaulay duration. Let's call it MACD. So MACD, which was in years, right, is used to calculate the mod D. And mod D is in percentage terms, right? This tells you how sensitive your bond price is to changes in interest rate. Specifically, 1% change in the interest rate. So if in the interest rate goes up 1%, right, how much will your bond price come down in percentage terms? That is what your modified duration tells you. And when I say bond price, I mean the full price, right? So it's not just the flat price or the clean price. This is the dirty price or the full price, which is measured against a shock of 1% to the yield. Now, if we break up duration into two measures, which is yield and curve, there is something known as effective duration, and this is what we will look at in the next learning module. It will be covered in later learning modules. In this learning module, our focus is on the yield, right? And what does that mean? If you go back to this relationship that we discussed earlier, and we talked about a convexity in this relationship. Now, these measures such as modified, money, and price value of a basis point, they are linear measures in the sense that they will try and tell you the slope, right? The slope which is going to measure the change in the bond's price, let's say your yield is going from here to here. So the bond price is going to go up clearly from here to here, right? If the yield is going to go down, the price is going to go up. But what they will measure is across this straight line. Even though the reality is that it's a curve, right? So if you're going to measure across a straight line, you're going to be a little bit off because as per the curve, the price is going to be little different than what your straight line is giving you. So that level of fine tuning will be discussed later with the curve duration. First, we're going to understand if we do it on a straight line basis, right? What is the relationship? And then later on, we will try and fine tune that little bit remaining amount, which is the difference between that straight line and the curve. Right, so just a recap from the last learning module that we talked about Macaulay duration, which is the weighted average time for you to get back your money. And that is calculated with weights given to each of the years, right? So it's in number of years, how many years it's going to take you to get your money back. Now, what we do is we take the Macaulay duration and the MACD divided by 1 plus the yield to maturity gives you the mod D. This is how you calculate the modified duration, assuming you have the Macaulay duration. And as you saw in the last learning module, that calculating the Macaulay duration is a lengthy process, right? You have to calculate the present value of each of those payments and then multiply it with the respective years. So it's very low chance, it's highly improbable that you get the calculation of Macaulay duration in the exam. Most likely it's going to be given to you. So they'll give you MACD, right? And you just have to plug it into this formula to calculate the mod D. And of course, we're talking about annual yield here. So what does that mean? It means once you calculate the mod D, now this modified duration that you have calculated is going to tell you how sensitive the bond price is to 1% change in interest rate. And of course, it is an inverse relationship, right? It is an inverse relationship, which means if the yield goes up, the bond price comes down, and if the yield goes down, the bond price goes up. So if the yield is going up, well, the bond price is going to come down, and vice versa. If the yield is going down, the bond price is going to go up, hence this negative sign. But how much does the bond price go up and down? For every 1% change in yield is the modified duration that tells you how much the bond price will go up or down. And we are talking about the annual modified duration and the annual yield over here. Now, as always, the concept is best understood with an example. So what I want you to do is calculate the mod D, right, over here using the MACD. And I'm not writing the formula, I'm assuming you remember it. So please pause the video and calculate the mod D. Right, so hopefully you remembered the formula that it is the MACD divided by 1 plus R, or the YTM, that will give you the mod D. And that is going to be your 1.87 MACD divided by 1.05, which is your 1 plus the YTM. And that gives you 1.78. Now, what does that 1.78 mean? It's not in years anymore. Now, this means that if you increase your YTM 1%, your bond price will fall 1.78%. So this is in percentage terms now. All right. Now, as I discussed earlier, is that the Macaulay duration is difficult. It's not difficult to calculate. It's just a lengthy process, right? It's a lengthy process. Even the formula is very complicated. Highly unlikely they ask you to calculate in the exam. However, what is more likely is to calculate something called approximate modified duration, which is not calculated through the Macaulay duration. The modified duration is calculated using the Macaulay duration. So MACD divided by 1 plus the YTM gives you the mod D. But if you want the approximate modified duration, there is another method of calculating this. So what we do over here is, let's say you know the price of a bond, right? You know the present value based on the current yield, and you can calculate this by now, right? If you have the data of N and the payments which comes from the coupon amounts, you know the current yield, right? And future value, you know, which is the face value, you can calculate the present value. What you can also do is shock the yield a little bit to both sides. So let's say 0.5% on both sides. You shock the yield 0.5% on both sides. And what that does is, with a lower yield, you get a higher price, and with a higher yield, you get a lower price. And you just know that, okay, what is this change in price compared to the change in yield? And you manually kind of calculate the slope of this line. Well, it doesn't come over there. Actually, if I draw it properly, it's coming up on the next slide, but the reason I'm drawing this over here is so that when you actually get to the next slide, you will be able to understand the diagram in a better way. So let's say the yield we are shocking here and here, right? Now, if you connect these two dots, the line that you're getting is not on the curve. It's not on the curve. It's a straight line, of course, because you're connecting the dots, and that is the slope that you're going to estimate by connecting these dots and calculating the slope, which is going to be this rise over this run. Slope is rise over run, right? So we will take the price. So when your yield is going down, we call it the price negative. Why negative? Even though it's a higher price, because that is for the lower yield. So for the lower yield, we get the P minus, and for the higher yield, when the yield is going up, we are getting the P plus. So this is what confuses students a lot in the formula, which you're going to see in the next slide, is that the rise that we are calculating is P minus minus P plus. So P minus is basically that higher price of bond when you're shocking the yield to the downside. So P minus minus P plus tells you that rise, and over the run, so that is your change in YTM, whatever you're shocking it by, into 2, because obviously you have to add these two together. And of course, the assumption is that you're shocking it equally on both sides. So if it's 1%, it's 1% on both sides. If it's 0.5%, it's 0.5% on both sides. So you just take one of that, right? Whatever you're shocking it by, multiply it by 2, so you get the entire run. And what you want is to have them both in price terms. So you also multiply this with the price, starting price, or P naught. And this is how you calculate the slope of this line. And if you remember from your high school maths, y2 minus y1 over x2 minus x1 is what we used to do to calculate the slope of a straight line. So this is basically what's happening over here. Now, in the previous mod D calculation, the mod D that we were calculating based on the MACD was making the line tangent to this point over here, right? So if you actually take the approximate modified duration, this line is the approximate modified duration, right? Whereas this line is the mod D. So the mod D is a little different from the approximate modified duration. Anyways, so here's the formula, and from an exam perspective, you need to be able to, number one, calculate the present value, which is going to be your P naught or PV naught, right? And how do you do that? You have to be able to read the question and be able to say what is the number of periods, right? You have to be able to read from the question what is the I by Y, what is the FV, read from the question based on the coupon rate, what is the PMT, and calculate for PV. And then shock the yield and calculate the PV plus, which is for a higher interest rate. So when interest rate goes up, the price goes down. So PV plus is actually going to be a lower price than PV minus, because PV minus is when the I by Y is going down, right? But the price will be higher. So don't get confused with this. PV minus is the higher price and PV plus is the lower price, divided by 2 into the amount that you're shocking the yield by. So that could be 0.5%, it could be 1%. But since you're shocking it on both sides, so you multiply it by 2, right? And then to have it in price as well in the denominator, you multiply it with the original price. And this is how you get the slope. And now you see this infographic, and hopefully it makes a lot of sense to you, that this line that you are calculating between these points, so this is your PV plus, the price comes down when the yield goes up, and this is your PV minus, the price goes up when the yield is reduced, right? And this slope is the approximation, right? If, however, we were using MACD to calculate mod D, it is this one that we would have gotten. So it is a little bit different to what the MACD gives you. But either of them, by the way, are not accurate, because you still remember that even if you get, let's say for this yield, if you get this price, it will be different. And even this price is little bit different, because the reality is that we have to even account for the curvature, right? So this one is giving us a more accurate price because it's still on the curve. But if I wanted a price somewhere along this line, it will still be a little off the curve, right? It will still be a little off the curve. And if I use this line, the price it will give me for this yield is definitely off the curve. So what we will look at in a later learning module is how to make that adjustment for the curve duration. But for the time being, just focus on your yield duration, that either you come up with this straight line or you come up with this straight line. The top one is the approximate one and the normal one is your mod D mac D one, right? So what are the steps? Obviously you have to shock the yield by the same amount on both sides, right? Calculate the price when the yield is going down, price is going up, calculate the price when yield is going up, price is coming down, and use that to calculate your approximate modified duration. And then you can even use that to reverse calculate your MACD, which will obviously also be approximate then, right? So as you know, MACD divided by 1 plus YTM was giving you mod D. So now what you can do is, if you have approximate mod D, you could just take this side over here, right? Which means mod D multiplied by approximate mod D multiplied by 1 plus the YTM will give you approximate Mac D. As always, it's best to solve a question. Now, before you pause the video, I just want to help you out a little bit. Because I'm sure you can do it, but just to save you some time, let me just quickly remind you what was the way to deal with accrued interest, because there is some accrued interest in this bond. So it's a 6% US Treasury bond, and you know these are semi-annual. Even if it's not mentioned, you should know that T bonds are semi-annual. So the I by Y that you will be dealing with is going to be have to adjust for semi-annual, which means half, right? So if the current yield is 10, so the I by Y you should take should be 5, point number 1. Point number 2, the payment that you're going to calculate based on this 6% should also be the semi-annual, which is going to be 3%, right? Of, let's say, 100. So the payment is going to be $3. Number 1. Number 2, N is going to be how much? You've got the current date as 15th November 2014. So how many days is that till the next coupon payment, which is 15th Feb? 15th Feb, and that's going to be 2015, and this is going to go on till August, and then Feb, and then August, and then Feb. So this is August 2015, and then Feb 2016, and then August 2017, right? And then it's going to mature. So how many, what n are you looking at? You're looking at 1, 2, 3, 4. Is that right? 15th Feb, 15th August, and then 15th Feb to 15th August. And then, no, sorry, there is Feb 2016, and then August 2016. And then you've got Feb 2017, and then August 2017. So that's 1, 2, 3, 4, 5, 6. So n is equal to 6. So I helped you with the n, I helped you with the I by y, I helped you with the PMT. Future value, of course, straightforward, is 100. And the PV that you will calculate will be obviously at this point, right? But you're not at that August 2014 point, you are in November. So you're in November 2014. So that PV you need to push forward a little bit. Now, how much are you going to push it forward? 92 days of the 184, right? So whatever PV you get, you need to push it forward 1 plus the R, and for the full year, let's say, or let's take it for 6 months, for the 184 days, if it is 5%, right? So then that will be 92 over 184, which is basically half, right? So you need to push this forward 0 to the power 0.5. So whatever PV you calculate, you need to load it up with interest and push it forward for half of this 5. Because this 5% is for 6 months, and you've got, out of that 184 6-month period, you've got the 92 days already done with that. So we need to load up the little bit accrued interest into this to get the full price. Now that's how you calculate your PV0. What I want you to do now is calculate the PV minus and the PV plus by shocking this yield. And how much do we need to shock it? 50 basis points, right? 50 basis points, which means this will become 5.25 and 4.75. Why? Because the 50 basis point is being shocked to the annual yield, so that is becoming 10.5 and 9.5, right? And 10.5 divided by 2 is 5.25, and 9.5 divided by 2 is 4.75. So what I want you to do now is shock the yield 25 basis point up and 25 basis point down, and use this to calculate the PV plus and the PV minus, and then again bring it forward for that 6-month period. But then again, the yield you'll be using will be 5.25 here as well, or 4.75 here as well, and then calculate the modified duration. So try it. Maybe you will get it right, maybe you won't, but the important thing is that you try, so that when you see the solution, you know if you did something wrong, you're able to remember that. So please pause the video and try to do it. Right, so hopefully this is your PV0, right? Which is based on your n of 1, 2, 3, 4, 5, 6. So your n is 6. Of course, I don't expect you to solve this manually like this formula is shown. Use your calculator. N is 6, FV is 100, PMT is 3, right? The 3% because it's semi-annual, so 6 divided by 2 Your I by Y is 5 right now. We haven't shocked it yet, right? It's 10 divided by 2. And calculate your PV. And then that you need to load up that PV for 3 months, right? So you take that PV that you calculate initially and you load it up with some accrued interest. So 5% is for 6 months, but we only have half of that. So 92 over 184, which is basically 0.5, right? So you load it up with the interest and you get your PV 0. Now you shock it up 25 basis points and down 25 basis point. Well, actually we're shocking it up 50 basis point and down 50 basis point, but because it's semi-annual, it gets divided by half, right? And you get your PV, which you then load up for the accrued interest, and then you get your PV minus and your PV plus. Then what do you do with this PV minus and this PV plus? Of course, you calculate the distance between those two, divided by 2 into the shock amount, right, into the PV 0. And look how the shock amount is for the full 50 basis points, because that is done on an annual, this is annualized. So the annualized approximate modified duration that you get is 2.41, and you can use that to calculate the approximate MACD. So hopefully guys, you were able to do it. Even if not, it's okay, right? This is your first time if you're seeing this concept. So if you made an error, it's all right. You know what error you made, and now you can go and do more questions from the question bank, so that you are able to make sure you are a master of this concept. And in the next video, we're going to get into money duration and the price value of a basis point.